Stay.
So, yeah. So,
I'm taking the midterm like halfway through class.
I'm sorry.
I'm taking the midterm halfway through class.
Oh, today?
Yeah, we
Okay.
talked about that last week.
Okay.
How should I like go about doing that?
At the break, we'll figure it out.
Okay.
You'll just be going to the main math office.
Okay.
It's like my last year. I was walking here on the library, right?
Oh, you.
This one just doesn't charge. So it's like, yeah.
So it's like on a one-time use.
Oh. Okay. I was here with my library. Like the library place now, and then these. I was walking down. I was like, one more step down.
About 20 seconds. Okay, folks. So, did you know spring break's coming up? Were you aware of this fact? Yes, keenly aware. Countdown has begun, hasn't it? So we have this week, the next week, and then the week after is spring. It's 3 weeks before spring break, basically. So this is our unit. We are going to be finishing on the 20th, I think, the Thursday before break. I didn't write the dates. Oh, I think I have the dates somewhere. I think I did put them here. Here's something. Okay. So I have one quiz. It'll be on Wednesday, March 12th. That is day 4 of our unit. And it's on the first 3 days. And then our test will be Friday, March 20th. I feel like it may be Thursday. I feel like I made a mistake. It's right before. I'm pretty sure that's a Thursday, actually. Yeah, probably Thursday, March 20th. I don't know what else. But it's already up on the Hub calendar, so that is ready for you there. Okay, today we are switching gears completely. We're talking lots about polynomials. How'd you like the polynomial function unit? You got used to it, the possible rational zeros and all of that. Today we start trigonometry. And you've studied trigonometry before, didn't you? We need to check to see with your neighbor if they remember a 9-letter word that is kind of key to trigonometry. 9-letter word. And it is a nonsensical word. What's the word? Wait, what is it? SOHCAHTOA, does that sound familiar? And that's just a way to remember that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, right? Like ka. And then toa is tangent is opposite over adjacent. We'll be talking about that later on in this unit. I just want to see if it's still there. We do have a little bit of a warm-up. Another throwback for you. Dun, 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 dun. No? What's wrong with this? Did I not draw that circle nicely enough? That's freehand.
So how do you find a shirt? I think to some point, yeah. You said comments and
Oh,
yeah.
Yeah, talk it out.
I think so. Because it's like I. You'll link the thing, so I don't. No, wait, no, what's it, please? Oh my god. I'm sorry. What else?
Oh, 6. The language of one of them.
Oh, yeah, yeah. I think it's really the yeah, that's 80, so you. No, track. Right. You. Yeah. Oh, fuck, I get, I like get what you're going. The other ones are trees, standing area for a second. There's out of the one.
Almost done? Do you have the answers already?
Someone.
You don't have plans for companies. We do integrated. You never studied circles.
Wait.
But what do you study?
No, it's so it's also a lot of work. Oh, wait, right?
What was that?
Even Isabel. Third grade was like science. She was like.
Oh, wow.
Wait, like I like most people in college go, well, it's alright, I like those class.
Obviously, he's not. Sure.
I've worked and some. Like she like that. I know. I'm still like one. Yeah.
Thank you.
So you're.
So just pay close attention.
Oh, wait.
Sure.
See that?
Oh, good question.
Science.
It's not right.
So that's something. Wait, math. This is weird. Because, you know, I literally.
No, that's.
I meant French. Oh, yeah. I love French. Oh, she was French. How do you do memory? My teacher.
No.
What? As you do.
About ready to go over these?
My jobs.
Just like the.
Maybe that's a nice circle. Okay. Let's talk about these. So I just want to hear what you think about these. Circumference of circle P. Katie, how do you do this?
Said circumference equals 2 pi r.
Is this true that circumference equals 2 pi r? Nice. So
You just plug in 10 per r. And then you get 20.
20 pi. And if we want units on this, it should be 20 pi.
Wait. Just inches.
The inches or square inches? Circumference is a measure of length. So it's just how far is it around that circle? So 2 pi. Very, very nice. Do you know why circumference is equal to 2 pi r? Do you know where that comes from? Let's talk about that just a little bit. I'm going to rewrite this 2r pi. 2r is just another way of saying diameter, isn't it? So circumference is equal to diameter times pi. And if I solve for pi, then we have pi is equal to C over D. And that is just the definition of pi. Does that look familiar? And by definition, pi is the ratio of a circle circumference to its diameter. So the formula for circumference just comes from the definition of pi. We'll probably hit on that again. Katie, thank you for your help. Number two, Haley Cave. What does number two even say?
Is M like the measure of AB?
Good question. Is it the measure of AB? Is that what the M stands for? M does stand for the measure. And when you say AB, you mean because there's something over AB. So it's the measure of
The like the curve.
the curvy part, which is called three-letter word,
The arc.
the arc, right? The measure of arc AB. Were you able to calculate this one? Pretty tough.
I'm not sure if I did it right.
Ah.
I just did 80.
Is it 80? What are the units?
Oh yeah, inches.
Would it be
No, that's
degrees?
good.
It's not inches, it's degrees. Very difficult calculations. Just take the measure. What angle is that called? Do you know what kind of angle that's called when the vertex is at the center? It's called a not center angle, but central angle. Are these bringing back some memories, maybe? For those of you who took geometry at some point? Not really. No. Well, that's a central angle, and when it cuts an arc, that we talk about the measure of that arc as being the exact same as the degree. So it's not like it's difficult calculation. You just have to remember to extend it to that. Thank you. Just for fun, and if I were to do something like this, the measure of that angle, which goes to the circle now, is now, yeah, divided by 2, 40. And I think I put a couple of those on the date before. So, Haley, thank you. Length of arc AB. I want to volunteer for this one. How are we supposed to figure this one out? Yes, maybe.
Like do 360 over the and then like
Do wait, 360 on top or 360 on the bottom? Okay. So 80 over 360.
Yeah.
Times the circumference, which we found out is 20 pi. Does this make sense? Right, circumference is the length all the way around. We don't want the whole thing, so 80 out of 360. Does that make sense? We just multiply it by that fraction. Like if we were 180 out of 360, that would mean we'd be taking half the circle.
this is just like 4.
So it's about 4.5.
Or like yeah.
Yeah, there's definitely some simplifications. I'm just gonna leave it without decimals. So I think 4 goes into both of these. Oops. 2 times and 9 times. So did I do this right? 40 pi over 9. And what would the units be here? Are the units inches now? Yeah, we're talking about the length, the inches. Now, if this were the answer to a word problem, that'd be a terrible answer, wouldn't it? It doesn't give us an idea of any sort of length there. So it would be appropriate in that case to use a calculator and get nearest tenth or something like that. But that is a perfect, exact answer. Maybe thank you for the help. Any questions about that one? Is it coming back? In this unit, by the way, we're going to be using lowercase s for arc length. So I'll just go ahead and put that up there. Why s? I don't know. It's a common one to use for this. Number 4. I am going to call on some lucky individual for this one. Haley R. Can you help us with this? No. I'm sorry, I heard pi squared and then I didn't hear after that. Okay. So 100 pi. Nice. 100 pi square inches. Do you need a calculator to approximate 100 pi? Just checking with your neighbor, what is 100 pi for type that into your calculator? Don't type it into your calculator. 314, right? Would you kick yourself if you plug that into a calculator and then afterwards saw that's 314? Should. Would you just take a moment to check with your neighbor how many digits of pi they remember? Just out of curiosity.
I don't even know.
Hmm. Okay, Ellen? Yeah. Yeah, unless it says approximate or round to nearest such and such, leave it as pi. Yeah, so normally you don't need a calculator. What, can you please show me the next digit? 3.14. Please show me the next one. Show me the next one. Show the next one. Oh, people know. Okay, after this one. 2. Okay. It is 6. Nice. That's all I know. I'm saying 5 after that. 3. Maybe how far could you go here?
I think I memorized like 50.
What?
Did you? How far could you go now? But just to we're comfortable just with this 5. It's there. Okay, so wow. Okay, interesting. Did you have to memorize these, or like was it like part of Pi Day at some point? Do you know how many digits the record for pi is? Memorizing. It's a ridiculous amount. It's like 45,000 digits. And guess how long it took them to memorize this? I think it was an hour because of how their mind works. The quote was, I got stuck on about the 20,000th place, but once I got past that, it was okay.
Okay.
Isn't that crazy? Imagine having that kind of recall. Yeah, and they're just reciting it. It took him a day or something like that. Yeah, to say it. Imagine, and it's gonna take a long time. Luckily, they made a song about it. I'm just kidding. There's no song up to 45,000 digits of pi. Okay, so we got this. For 5, I need help with 5. Do you remember what a sector is? Yeah, it's a slice. It's the area in between the two radii and the circle. So to do this, yeah, all right.
Percentage of the total area was equal to sector is, so we found out earlier it was 2/9 because we did 80/36.
Okay, so we're gonna use what we did before, so 2/9, and then do what with that?
That find the total area is equal to.
Are we good with that for calculations? I really like how you're using the work from before. We don't have to do work again and again. It's the same problem. So this is exactly 100 pi ninths square inches. And if you wanted to, oh, is it times 2? Oh, times 2. 100 times 2 is 200. Thank you. Are we good with this? Oh, by the way, for number 2, there really are 2 answers, aren't there?
Yeah, like the other way around.
You could go the other way, in which case it would be 280. So we normally assume that there are 2 types of arcs. We assume it's the short way, which is called the minor arc, as opposed to the major arc. And normally if I would talk about the major arc, I would do something like this and talk about it being ACB. So it's fair to assume the minor arc when we're talking about arc length, arcs and sectors and things like that. So I hope you like this throwback. It's a blast from the past. Shall we start the the packet? Let's do it. Angles. The main ingredients of an angle. Some people say it's a pointy thing. Is that a good definition of an angle? It could probably be applied to pointy things, but some people say it's two lines. Is that a good definition? Two lines intersecting. Is that a good definition of an angle? Think about that. Two lines intersecting. Is that a good definition of an angle? Please discuss with your neighbor. Is it a good definition? If not, what would be better? A definition. What's a good definition? Anyone want to offer a guess or suggestion? I know you know what it is, but defining it is a little bit strange. It's pretty abstract. Main ingredients for an angle? Could we say that it needs a vertex? Is that an ingredient? I'd say the vertex is a feature. I wouldn't say it's an ingredient. So what are the ingredients for an angle? Lines? Are we good with that? Because I would think if it's two lines intersecting, is this an angle? It has angles, but we could see that there are four angles here. So I think it's a little overkill. So really just to get an angle, we need the smallest ingredients we need would be, what is it? To raise. Does that make sense? So by definition, so to raise. So like this. Here we go. Is that an angle? So two rays with a common, do you remember what it's called? That point of a ray? It is called, yeah, with a common endpoint. It's kind of strange because that's where it begins. So yeah, two rays with a common endpoint. That is an angle. Now we don't always include the entire one. Like this is an angle, isn't it? Let me draw it so it's not weird. That's an angle, but it comes from the two rays that are going that direction. Just to be clear about what an angle is. You'll notice that the angles here have a terminal side and an initial side. I should say that in reverse, an initial side and a terminal side. Initial just means where the angle begins, and then terminal is where it ends. The angle is just talking about the difference of directions, right, Ella? What's the difference of direction that these two angles are going in? And normally we use Greek letters. Like, do you know what this letter is here on the inside? That is an alpha. We could measure it this way. No one says we have to go the short way. Notice what they've labeled it here. It's not alpha, but beta. And that's just arbitrary. Does this make sense that this is another way to measure the angle? Not only the long way around, but the super long way past the destination and come back to it. That's another way to measure an angle. In this case, notice that there are arrows. Notice where the arrows begin. That's the red arrows. They begin at the which side? The initial side and end at the terminal side. So what's the difference in direction to go from the initial side to the terminal side? Standard position of angles. Do you know this letter here? This is a theta, yes. And I'm gonna spell that out because some people get confused with the cheese. Which cheese am I talking about? Theta, yeah. It's not an F, it's a TH, theta. So please make sure you're saying it correctly. Yeah. And so standard position means the initial side, right? Standard means we could all agree on one answer. Standard position, the initial side is always in the positive direction of the x-axis. And then the terminal side is somewhere else. And for standard measuring, we measure counterclockwise like that. So there aren't two answers. Unless it says to find another measure. But if I'm talking about an angle in standard position, that's what it starts at initial in this direction, and then it has a terminal side. The vertex is always at the origin. If we're putting on an axis. Okay. Let's see what you can do for these. I think you already do it. Just draw it first. We'll talk about the coterminal in a minute. Just draw these. Just make sure your neighbor is drawing these correctly. All three, please. A, B, and C. No, we do not. Good question. Just draw the angle. Why have I included these horizontal rays going to the right for all of them? It's standard position angle, so that's where they all begin. For A, would you please show me where it ends? Your pen or arm? Yeah, there's just one answer here. We should be going up this direction. And we can mark that 45 degrees. Please show me B. Where does that end? Yep, straight down. And we could either label it with a 90, or you could include a thing called a little boxing. Is that what you call it? I don't know if it has an actual name. It must. Right angle mark. Yeah. 420 degrees. Would you please show me which direction that goes? The terminal side is what, like this? Something like that. And if I want to label this, I'm not going to tuck the 420 degrees in here. That wouldn't make sense, would it? That'd be a little strange. So to mark this, I am going to trace the path that I went and put that 420 degrees right there. Easy. There is a vocabulary word. State one positive and one negative coterminal angle. Let's see if you can figure this one out. Discuss with your neighbor. What do you think the answers would be for A? So would someone like to venture a guess for A? They won't get a number they like to put forward. Well, do you understand the word coterminal already? It's another angle with the same terminal side. So we can't change either side, but we can change how we get there. So instead of 45 degrees, coterminal would be, what's that? 230, did you say? 30 degrees? We have to start at zero. We have to start at zero. That's to be standard. You would go the other way, which would be negative 315. Does that make sense? That'd be coterminal angle. So coterminal. negative 315 degrees. And it's negative 315 because we're going clockwise to get there. That's just standard. Yes.
So we go like all the way around positively, then back up.
What do you think? Would that make sense? 405? That's exactly what I'm looking for. Yeah, maybe?
This is not like
Angles are specifically made up of rays, not lines.
Correct.
like all.
Yes, and lines make four different angles if they intersect.
Yeah, because then like the terminal line.
Yeah, so when we're just talking about the angles, right? We're just talking about angles here. So it's just the rays. You can imagine a clock like you're talking about the hands of a clock. So with how many degrees does it have to go to make the same angle? Right? If you introduce the line, it gets super confusing. So it's just the rays. Yeah, either one of these. How many more coterminal angles are there? Infinitely many. You could go around as many times as you like. Normally you simplify it, right? You make the smallest one 45 degrees, but of course I'm going to put other angles on the test and quiz so you can see them in different colors. I'll give you moments to work on B and C coterminal angles. I will be calling on a couple people for these. I think I will put in here that we went negative 90 degrees, just to be clear. Did you get him? Okay, calling someone? It's too soon? Not Joanna. Not Kyson. Okay, so Kara, can you tell us what you got for B? Negative what? Negative 450 and 270 degrees. Do we agree? How do you know this?
I took negative 360 and positive 360. And then I added whatever the angle was. So negative 360 plus negative 90 is negative 50, and 360 plus negative 90 is 270.
Are we good with that? Did anyone think about it a little bit differently? I love what you did. The way I think about it is I start with that negative 90 and from there, add 360 and subtract 360, which I believe is exactly the same thing that you said. So however you'd like to think about it. Thank you, Kara. No Elise either. No Jojo. My goodness. But Mackenzie, you're here. Thank you for being here. Can you tell us what coterminal angles you got here?
Well, like, so you would do like 80.
How'd you get that?
Wait, no, sorry, not 80, 60.
How'd you get that?
420 minus 60.
I like it. Yeah, so you got 60 degrees. Okay.
I don't know, I feel like the other one, I don't know, correctly, because it would be 720. But that-
Positive 720 or negative 720? Yeah. But the way you said the answer makes me think that you're guessing. So let's see. I got that 420 to the 60. 420 going to that 60. Where did that 60 come from?
Subtract.
Subtract 360. And 360 we know is one full revolution. So I agree with you that that's 60. So if we want to continue to go negative, what do you think we should do to that 60? I like that idea. Now, I'm not going to say 60 minus 360. I'm going to say 360 minus 60. Then make sure our answer is negative, which leads us negative 300. Are we good with that? Any questions? Thank you, Mackenzie. Now, and I think you said 720. Yeah, I'm not sure about that, but definitely if you're adding or subtracting 360, you're going to get another coterminal angle. And we could continue to get more if we wanted to. Any questions? Okay, before we get into the next part, I'm just going to give you until what time is it now? It's 08. We'll start up again at 11, 10, 11. So just over 2 minutes to stretch, zone out, whatever you need to do. Hmm.
It's genuinely. So. Yeah, I'll talk to you. No, I know. I opened the form because I was like, oh, it's gonna be quick. And then in the form, you have to go open another link. I don't think it's like stuff. And then you have to read three of these. No. Dude, and then you have to write about those three. Just to go through. Yeah. But she didn't really say when their dues were, and then all the dues are Thursday, yeah. I know, but it was really embarrassing because I didn't see the other two, like, and then she would write my name, your name on the board. You didn't do it, so I was like, okay, so that was my emotion. Yeah. Okay. Sorry. Did you say what?
But like, I look here and say it that way. All right.
Yeah.
Yeah, finish up your conversations and go on back to your seat. Going back to your seats, please. Okay, so you may have heard right now, up until this moment, really, the only way that you have learned to measure differences, measuring the difference between two rays, is with a sort of measure called degrees. Yes? And I think you're all comfortable with the fact that one revolution is 360 degrees. I think it's kind of intuitive, but is that a natural number at 360? Like, is that just like kind of born with that information? If you never went to school, you would just know a circle is 360 degrees. It's kind of arbitrary, don't you think? So there is another way of measuring differences between angles or between rays. It's called radians. Have you heard about this? Have you heard about radians? So I'm gonna give you the textbook definition first. And then I'm gonna go over a way to make it as intuitive, hopefully, as degrees. But yeah, let's start with just the idea, like why is it called a radian? I want you to imagine the radius of a circle. So here we have a radius of a circle. If we were to cut this out of yarn, focusing up here, if we were to cut this out of yarn and then wrap it around the circle, the length, well, you can see that it would go this far. And we would call that the measure of that angle 1 radian. How many degrees do you think that is approximately? 50, 60? I want you to imagine this circle now cut in half and discuss with your neighbor how many radians would it take to go around past the circle.
3.1.
Okay.
So 180 degrees is about the same as how many radians did you see? Approximately. It's a little bit more than 3, specifically 3.1415926-ish radians. So we would say that 180 degrees is actually equal to pi radians. Or 360 degrees is equal to 2 pi radians. Yes, maybe. Great question. One of the points is that it makes the math work out nice and pretty, as you'll see in a moment. But another way is to just take out the humanity of our numbers, like the fact that we're humans. It's 360 degrees because I believe it was a Sumerian approximation of days in a year, 360 days per year. So one cycle being 360. It was not a great approximation, but it came from that. So just a way to take out the humanity from the numbers. Like if we were to communicate from a species from another solar system, that pi would probably exist in a scientific sense, the ratio of a diameter to a circumference. But you'll see what I mean by making the math work in just a moment. Because it is kind of annoying. It's like you did all this work with degrees, and now here we are switching up to radians. But it's in the language of science, it's very important. So here you see the 3 radians. So 3.14159 radians would be about that half a circle. You see that kind of animation happening there. Okay. This one. Circumference, I'm gonna do some pre-work here. We know that circumference is equal to 2 pi r. S. What does that little s stand for? The measure of the arc, the measure of the length of the arc. But the length of the arc. So if I want this, I'm gonna have to multiply this by, I'll use theta here. Theta over 360 times 2 pi r. Or if we're in radians, it's going to be theta over, instead of 360, what do you just check in with your neighbor? How many radians is 360 degrees?
Oh,
360 degrees is 2 pi, isn't it? Times 2 pi r. Now take a look at the math on that second one. You notice what simplifies? It's just theta times r. So we have that the arc length is equal to theta times r. This is one case where the math just works out a little bit prettier. Yes. Radians. Ah. R represents, just like it did before, the length of a radius. So where do we put the radians? That is theta. That's the measure of that angle. So let me put that here. So this is measured in radians. As opposed to this one, which is measured in degrees. It's 360 degrees. Yeah, so the radius and radians are related to each other. But do remember, and thank you for pointing out this difference, that r is the length of the radius specifically. So from that s equals theta over r, we have this other formula, theta equals s divided by r. So if you want to know the angle and you're given an information of arc length and radius, all you have to do is find the ratio. So a central angle theta in a circle of radius 6 inches intercepts an arc length of 15 inches. What is the radian measure of theta? We know that's equal to s over r. Theta is equal to, and s in this case is 15. I'll put inches there. The radius is 6 inches, leaving us with I think I'll divide both of them by 3. So 5 halves, or 2.5 radians. Yes. Sure. Are we good with that? 2.5 radians? The symbol for radians is nothing. If you leave it blank, I'm going to assume you mean radians. If I tell you an angle measure is 3, your assumption is 3 radians. I will put it here. If you want to put rad, you could do that too. There are some books that may put like a to the R or something like that. Not our book, but we'll just write radians if necessary. Any questions? Okay. Conversions between degrees and radians. Have you done conversions in your science classes? Let's take a moment. Let's take a moment to just do a little exercise, like a mid-class warm-up. I want you to convert 0.3 miles to millimeters using exact conversion values. You may want to discuss with your neighbor how you're going to do this. Let's do centimeters. Millimeters seems excessive. Centimeters. Great question. There's an approximation, but that's not exact. I think 1 mile is approximately 0 points. No, 1 mile. I don't know. I don't know miles to kilometers. 1K is 0.6-ish miles. That's 0.6-ish. That's not exact. So conversions, you're going to go from miles to I recommend going from miles to feet. From feet to centimeters? Nah, from feet to inches and inches to centimeters. I think that's the way to do it exactly. Okay, so 0.3 miles. What do I do with this? Is this how you do it? Something like this? Unit conversion? So miles will be on the bottom. 1 mile is equal to, yeah, how many feet? 5,000, 5,280. How do you know that? Such a dumb number, isn't it? You just have to remember it. I imagine you remember from science class. No, maybe it's just intuitive. Maybe just know from birth. I don't know. Okay, so if we do that math, then we'll have feet, but we don't want feet. We want centimeters. So we're going to go from feet to inches. So where are our feet going to go? Bottom 1 foot is equal to 12 inches. How do you remember that? Because you just know this stuff, right? Is that intuitive? At this point, it's intuitive. It's just Yeah, you've all seen a ruler. Okay, and now what? Inches go on the bottom. How many centimeters in 1 inch? It's exactly, by definition of a centimeter, 2.5. One more digit. 2.54 centimeters.
Like, no.
You don't have to memorize these. You should know 5,280 feet. And now, do you want to do this by hand? Me neither. So 3 miles is approximately how many centimeters? Someone do crunch the numbers already? There are different ways. 53,000 for 828. I'm hearing just two different things. I'm not sure.
280, that's.
48280, like this. Exactly. Point what? 0.32. Did anyone else get a number like this? It's just 0.3 times 5,280 times 12 times 2.54 centimeters. So if you got something else, chances are that you may have gone from miles to kilometers, and I think that the 0.62 is approximately right. But if I'm trying to find something as accurate as a centimeter, it's not going to be exactly there. It's just an approximation. So if we're converting from degrees to radians, really you just have to know like how many feet are, how many inches in a feet, how many feet in a mile, just how many radians in a degree or degrees in a radian. Yes.
Like round to like
Oh, sig figs. Yeah. Good question. In math, I always want as exact an answer as possible. Like if pi is involved, just leave it in terms of pi. But if it says round to nearest 10th or nearest 100th, I don't normally talk about sig figs. But if I say to approximate and don't give you like a degree of approximation, 3 decimal places of accuracy is what I'm looking for. If it depends on the level of accuracy I want. So in your it would be a calculator problem. So if you're using pi, use a pi button, not 3.14, which is a common error. So I'm just letting people know. So I'm not going to talk about how many 1 degree is, but I'm going to say that 100 and what just happened here? 180 degrees is equal to. Do you know how many radians this is equal to? About 3.14, but exactly equal to pi radians. This is what you need to remember. Okay, so 30 degrees. Okay, what goes on the bottom? Radians or degrees? It's degrees on the bottom. How many degrees? 180 degrees to pi radians. Does that make sense? It's done exactly the same way. It's a different unit conversion you have. What cancels? Degrees. And I think those 30s cancel. 30 goes into 180. 6 times, leaving us with pi over 6. Now I could write radians, or I could just leave it pi over 6. Remember, if it's blank, especially if it's talking about an angle measure, it's understood that it's radians. I'll give you a minute to finish the rest of these. As you finish them, check in with your neighbor, make sure they are getting the same thing you are. Make sure you're comparing with your neighbor. What they get. No decimals. If it's a fraction, leave it as a fraction. Did I call on you for example 3? Ready or not? See what you got. Sam, what'd you get for B?
I got negative 27 pi over 50.
Negative 27 pi over. Can you tell us what you did?
Yes, so I did negative 135 degrees.
Okay.
Pi radians over 180.
Okay. And you said you simplified it to negative 27 over 56. Where did that 56 come from?
Oh,
Maybe 36, I think is what you like. Okay. And now you can see that you can still simplify it by. And a pi there. I think I forgot to write that pi. Yeah, so negative 3 pi over 4. Are we good with that? Here? Good question. Could we have negative radians? You can't have negative inches. So could you have negative radians? What would it mean? Check in with your neighbor. Is it possible to have negative? What does it mean to have negative radians? Katie, you still have, you're not alone. Okay, show me what is negative radian, what do negative radians mean? Anyone? Yeah, Katie?
Instead of being up here, is it down here?
When you say down here, you mean it's going which direction?
Uh. Wait, what?
It could be down. It doesn't have to be down. Because we're talking about a circle. That means we're talking about a second. No, you're right on the right track. We have a terminal side. Sorry, we have an initial side and the terminal side. How do we get to that terminal side? Well, positive goes counterclockwise and negative, like you're saying, we start in a downward direction. That's negative. So it works for degrees or radians. So you're right, with inches, with a measure of length, it would never be negative. That'd be weird. But for angle measures, negative is very specific. So thank you. Charlotte, what'd you get for a C? Say that again. 3 pi over 2. Do we agree? Nice, thank you. May, what'd you get for D? Negative 5 pi over 6. Are we okay with this? Is it? Did I write that correctly? Negative 5 pi over 6? Over 3? Oh, maybe I misheard. Negative 5 pi over 3? Okay, thank you. Okay, for these, what measure are we talking about for A? How do you know it's radians? It's not specified, and it's definitely talking about an angle. Okay, so it's pi over 3. We're going to multiply this by what goes on the bottom? In this case, on the bottom is pi, and on the top is 180. That is a very, very important unit conversion. So is this difficult? We can see now that the answer is 60 degrees. I'll let you finish those for your own, if you want to do it later. Yeah. I think you do this already. I don't want to belabor the point. And I do want to give you at least a little bit of time to work on the homework. But before we do, we just check in with your neighbor. What's important about today? What do you need to remember? Chloe, what do you need to remember for today? From what to what? Specifically? Are we good? What else? Thank you, Chloe. What else we had to remember from today? Co-terminal angles. To get there, you either add or subtract. 360 if you're in degrees. If you're in radians, you'd either add or subtract 2 pi. Anything else? Standard form of angles begin where? Please show me the initial side of a standard angle. Yes, x-axis, positive direction. Cool. Take some time. Get through a couple problems.